Hi class, and welcome to another lesson. Today we're on section 6.9. We're doing more work with parabolas. However, today's lesson in 6.9 is very unique and different than the other lessons. So far, every quadratic that we've had has been y equals an x squared of some sort. You might see it in standard form or you might see it in vertex form, but the x is always squared. In which case, you get a parabola that goes up or it goes down. In section 6.9, we're not going to have any of this anymore. Okay? It's now going to be parabolas that go sideways. Sideways parabolas. So they're going to open up to the right or they're going to open up to the left. Now I want you to be very careful with this lesson because there's going to be a lot of similarities to the lesson that I taught you in 6.6 where we talked about graphing parabolas in vertex form. There's going to be a lot of similarities. However, there's a lot of differences as well, a lot of opposites. The way I kind of compare it is any basketball players in the class, if you are dominantly right-handed, you learn how to shoot a right-hand layup and it feels pretty natural and it goes well. Now in the 5th or 6th grade, you start to try those left-handed layups. And it should be the exact same thing, shouldn't it? I mean, everything is opposite, but it should flow the exact same way, but it feels very weird. It's very unnatural to do that left-handed layup. Any musicians in here, if you kind of think about playing the piano, for example, you see the treble clef with your right hand all the time. And your mind kind of gets geared that way, and then when you see the bass clef with your left hand, the notes are all the same, A, B, C, D, E, F, G, and then you have the sharps and the flats. But when you read the bass clef and the treble clef, even though the notes are the exact same, they're very different things, are they not? So that's kind of what I like to compare with these lessons, as we have the parabolas that we're used to that go up and down. These are kind of like our right-handed layups. They're natural. They feel very comfortable to us now. The sideways parabolas are kind of like our left-handed layups, or kind of like the bass clef. They don't feel quite as comfortable. But as anything, now professional athletes, they can, have right-handed and left-hand layups very equal. As you excel in your musicianship, you become very comfortable with whatever instrument, with whatever hand, with whatever clef that you're dealing with. The more times you do something, the better you get at it. Same thing with these parabolas. So, this chart here, what you are used to is this left-hand column. You're used to the opening of up and down. If A is positive, it opens up. If A is negative, it opens down. You're used to the axis of symmetry being x equals the x-coordinate, which is h. The vertex is at hk, and you are used to this form, y equals a times the quantity x minus h quantity squared plus k. So now, class, when I have x equaling a y squared, okay, you're used to y equaling x squared. But when it is an x equaling a y squared, a lot of these things are just the exact opposite. Okay? As you can see, your vertex still comes from hk. However, the y value is inside the parenthesis. The k value is inside the parenthesis. The x, or the h value, is outside the parentheses. So that's one opposite that you're going to see. Another opposite you're going to see is that the axis of symmetry in a up or down parabola is an x equals line. It's a vertical line. And it's x equals the x-coordinate, or x equals h. In a parabola that goes left or right, such as this one or this one, the axis of symmetry is going to be a horizontal line. It's not going to be vertical. So when that's the case, it's going to be a y equals line. And another opposite, instead of x equaling the x-coordinate, it is y equaling the y-coordinate, which is y equals k. So there's another opposite. Now, if it opens, if your a value is greater than 0, or if it's positive, you're going to have one that opens up to the right. You're going to have one that looks like that. If your a value is a number that is less than 0 or negative, it's going to open up to the left. So there's another, it wouldn't be opposite, but there's another difference. So there's going to be a lot of similarities. However, there are going to be a lot of differences as well. One more thing that I should say is we're used to when our A values are like 1, 2, and 3. This was like the up 1, right 1, up 3, right 1, that whole thing. Now that it opens up to the left or to the right, it's now going to be up 1, right 1, up 1, right 3. So this is another change that you're going to see. And I'll talk more about that in just a little bit. So this chart is also going to be similar. However, it is going to be very different as well. All right, let's just get on to our first one, if I can. There we are. So as you can see, we now have an x equaling a y squared. So these are going to be parabolas that open up left and right. Now on our notes for today, they're always going to be left and right, so you can kind of get your brain in that mode. However, on a test, I'm not going to tell you, hint, this one opens up to the right, or hint, this one opens up down. I'm not going to give you those hints. What you're going to know is if you see y all by itself on the left, you know that it opens up or down. If you see x all by itself on the left, you know that it opens up right or left. So this one, obviously, an x equals, it's going to open up to the left or to the right. Let's just fill these things in as we go. So our vertex is going to be at h, which is the value on the outside, which is this positive 1. And it's going to be at k. So right there. And just in the same way as our vertex form in 6.6, it's going to be the opposite of what is written in here. So instead of y minus 2, that y minus is part of the equation. So this stays. All we're taking out is the positive 2. So kind of think of it as the opposite again. Whenever it's in parentheses, you kind of think about taking the opposite. So our vertex is at 1, 2. Our axis of symmetry, it's going to be very tempting to just go, ha, x equals 1. And you would be incorrect. It is not x equals the x coordinate anymore. It is y equaling the y coordinate. Y equals k, or in this case, y equals 2. And then our a value is a negative 1, right there. Negative 1. So now we're going to graph this one. My vertex, I'm going to go right 1, up 2. And my axis of symmetry is the line y equals 2. So it's going to be a horizontal line right here at y equals 2. So this is going to tell you that this is your mirror. This is the fold line that's going to make the parabola fold on top of itself. Your a value is a negative 1. So the negative sign tells you that it is going to open up left. If it's positive, it opens up right. If it's negative, it opens up left. So then you're going to use your patterns for a. What you're used to doing, this is not correct, so don't write this down. You're used to going right 1, up 1, right 1, up 3. Left 1, up 1, left 1, up 3. Or, obviously being negative, you would go down. So kind of envision this for a second, class. This blue parabola, what you want to do is you want to turn it 90 degrees counterclockwise. So picture just turning this thing. I wonder if I can do that. Oh, that was a bad idea. Let's see if I can fix that. My vertex is at right 1, up 2. Okay, look good? All right. So picture turning this parabola 90 degrees counterclockwise. So what you're going to do here is your points are going to be left 1, up 1, left 3, up 1. There's our pattern for A. Left 1, down 1, left 3, down 1. And so these 5 points are what I require of you on these problems. If you're ever unsure of yourself, class, all 5 of these points satisfy this equation. So let's just prove that by picking one. It might be easiest to pick this one because one of them is a 0. This point is at negative 3, 0. So when x is a negative 3, y is 0, it should make this statement true. Let's see if it does. What is a negative 2 squared? It is a positive 4. A positive 4 times a negative 1 plus 1, that should equal a negative 3. Negative 4 plus 1 is a negative 3. Negative 3 equals a negative 3. So I know that this point works. I can do the same thing for this one, this one, this one, and this one. And they're all going to satisfy that equation. All right, so as you can see, it's a lot of stuff that we've already done before. It's just in a little bit of a different manner. It takes some getting used to. It feels weird at first, but the more you practice it, the better you're going to get at it. So now let's try number 2. Number 2 is going to be a little bit trickier because we have an a value of 1/3. We don't have a pattern for that, so I'm going to teach you how to do that in just 1 second. But the vertex is going to be at the h and k. It's going to be at the value outside the parenthesis is your x, and the opposite of that binomial is going to be the y-coordinate. So negative 2, negative 4. After doing that, you're going down to the axis of symmetry. The axis of symmetry, in this case, is going to be a y equals line. Y equals the y-coordinate. And our a value is positive, so you know that it opens up to the right, but it's 1/3. So here's how we're going to do that. Let's start graphing this. The vertex is at left 2, down 4. Left 1, 2, down 1, 2, 3, 4. My axis of symmetry is a y equals line right there. Okay, so now from the vertex here, what I have to do is I have to come up with some more points that satisfy this equation. One way that you can do it, class, is you could just put this into your graphing calculator. I have no problem with that. But I just want you to think critically for a second, okay? Let's pick a value for one of these. I would say it would be easier to pick a y value, and then we're going to get an x value. So what we want to do is we want to pick a y value that when we add 4 and square it, we somehow get a multiple of 3. Because I know I'm going to multiply by 1/3 here. So if I multiply by 1/3, it's the same thing as dividing by 3. So in your minds here, think for a second. What can I add to 4 that when I square it, I'm going to get a multiple of 3? Our squares are 1 squared is 1, 2 squared is 4, 3 squared is 9. Hey, is 9 a factor of 3? Yes, it is. So you know that you want this whole thing right here to be a 9. How can you get this to be a 9 if y is a negative 1? Because if y is a negative 1, work through this with me here, class. If y is a negative 1 plus 4 squared, a negative 1 plus 4, that would be a positive 3. 3 squared is 9. So now I have 9 multiplied by 1/3 minus 2. I'm picking a convenient point to plot on this one. So now what is 9 multiplied by 1/3? 9 times 1/3, or 9 divided by 3, is 3. 3 minus 2 is 1. So when I substitute a y value in of a negative 1, I get an x value of a positive 1. So this, class, is one of my convenient points. I'm going to plot this on my graph. So I'm going to go 1, negative 1. Right 1, down 1 from the origin. And now, class, we all know that parabolas are symmetrical. So this point above the line of symmetry should be the same point below the line of symmetry. How did I get to this point? I went up 1, 2, 3, and right 1, 2, 3 from my vertex. If that's the case, I got to go down 1, 2, 3, and right 1, 2, 3 from my vertex. And there we have it. Those 2 points are on my graph. In class, on this one, I only require these 3 points from you, because now we're off our graph once we get to right here. So this is enough for me. Connect these 2 points, these 3 points together rather, and there you have your parabola. This does take a lot of critical thinking, class. If you don't want to think of this table here and try to think of that convenient point, I have no problem if you put this into your calculator as well. So if you'd like to do that, let's practice that. We have y equals, it's going to be 1/3 times the quantity, 1/3 times the quantity. Oh, yeah, I forgot these are x equals and not y equals. Yep, that won't work on this one. Sorry, class, you're going to have to do it the hard way. You're going to have to try to come up with a convenient point, such as what I picked out here for a -1. There's going to be one problem like that in your homework. If you have any trouble with that, please come and ask me about it in class. But if you could get it on your own, that's great upper level math thinking. So that is how you graph these new ones where it's x equals a y squared. They're going to be parabolas that go to the left and to the right. Please let me know if you have any questions.